Hello, this is Mr. Martin. In this video, we're going to continue with transformations. We're going to look at a new type of transformation. In the last video, we looked at translations. That's one type of transformation. And in this one, we're going to look at reflections. So if you want to go ahead and give a try and read this reflected text here, go ahead and do that. And then if you want to pause the video and give that a shot, otherwise I'm going to read it. It says, "Can you read this message? Today we'll explore what happens when we reflect shapes. We get the mirror image." And this was adapted from Mathematic. Okay, so let's use the picture to the right here, this graph here, to answer the following questions. How far is point B away from the line? So it's a little bit hard to see, but we're going to try and count out the spaces here. We have 1, 2, 3. Okay, and just a little review from algebra. This is the line y equals 2. Okay, notice it's a horizontal line that goes through the y-axis, so it's going to have an equation of y equals, and where it goes through is y equals 2. All right, so it's 3 units away from the line. Now, if we want to reflect it over that line y equals 2, we have to move it the exact same number below or on the other side of the line. So we're going to go 1, 2, 3. So reflect point B over the line, label it B prime. So right over here, B prime. Reflect point B over the line, label it B prime. How far is the new point away from the line? Again, 3 units. Okay, however far it is on one side of the line, it has to be that far on the other side. All right, just want to remind you guys, anytime you have questions, feel free to pause the video and make sure that you get your questions answered. If you're not in class, you can write them down and make sure you ask the next time you see me. Okay, now for number 2, we're going to reflect an entire triangle. So we have this triangle JKL. And here's the coordinates of these. Here it's given to you what the coordinates are, but I always recommend that you start writing out the coordinates, and this is true for any kind of transformation, but you write out the coordinates and then it makes it easier to reflect them. All right, so we'll reflect J, K, and L over the y-axis. This is some key information. Then connect the points using a ruler, write the coordinates below. If you'd like to give this a shot, see what you can do, feel free to pause the video, otherwise I'm going to go through it. So we have to figure out how far each of these points is from the y-axis, and then we'll put the image of that point on the other side. So L is 1, 2 away from the y-axis, so we're going to go 1, 2 on the other side, so that's going to be L prime. And then J is 1, 2, 3, 4, 5. So we're going to go 5. 1, 2, 3, 4, 5. Let's see, this is at 0, 0, 5. So it's going to be 5 units over here. It's kind of hard to see where that point is, so we're going to estimate it right there. We'll call that J prime. And then K is at 7. So it's 7 away from the y-axis, so it has to be 7 on the other side at -7, and that's going to be K prime. And let's see if I can connect these with straight lines. That's not too bad. Oh, there we go. Okay, so we'll pretend that this connects here. We'll make a little bit bigger of a point there. Okay. So what pattern do you see in the coordinates of the pre-image and the image? Again, anytime you want to try and answer these, feel free to pause the video. So what we notice here is that all of these points are up or down the same amount from the y-axis. So for instance, L is 1 unit above the x-axis, and L prime is also 1 unit. So we see that all of the y coordinates for these stay the same. So y coordinates are the same. However, each of the x coordinates, for k it's 7, and k prime it's -7. For L it's 2, for L prime it's -2. For j, it's 5. For j prime, it's negative 5. So I'm not going to say that they're negative. What I'm going to do is I'm going to say x coordinates, y coordinates, x coordinates are the opposite. Okay? Because in this case, all of our original points were positive x's, and now they're negative. But if it happened to be a negative one and it was reflected over the y-axis, then it would be positive. So I like to say the opposite. All right, how do the sizes of the two triangles compare? Well, the triangles are exactly the same. Triangles are exactly the same. Okay, so let's use some geometry vocabulary here. They are congruent. Okay, and then again, I think I mentioned this in another video, the congruent symbol is an equal sign with a squiggle, and we're going to be using this all school year, so make sure you understand this notation here. All right, moving on to number 3, we're going to start with the same triangle, except this time we're going to reflect it. Oh, we didn't fill in our values up here. All right, let's go back and fill these in so we can really see that the y coordinates are the same and the x coordinates are the opposite. So j prime is going to be negative 5, 4. K prime is negative 7, negative 1. And L prime is negative 2, positive 1. So again, we can see that these are opposites, these are opposites, these are opposites. Okay, moving on. So we're going to reflect over the x-axis. So now we're reflecting over this axis. And so now, however far it is away from the x-axis, we have to move it that far on the other side of the axis. So J and L are above the x-axis, so now they're going to be below, and K is below, so it's going to end up being above. So L is 1 unit away from the x-axis above, so we're going to move it down, so that's going to be L prime. And K is 4 units above, so now we're going to move it 4 units below, so that's J prime. Now K is 1 unit below, so now we're going to move it 1 unit above, so that's going to be K prime. And let's connect these. There we go. Great. Okay, so let's put in our coordinates this time. So now all of our x coordinates stay the same, and our y coordinates are going to change the opposite. So this is going to be 5, negative 4, and this is going to be 7, positive 1, because it changes to the opposite, and 2, negative 1. So again, look at our pattern here. These change to the opposite. All right, what patterns do you see in the coordinates of the pre-image and the image? So again, the x coordinates are the same, and the y coordinates are the opposite. Okay? All right. So let's summarize this. And again, if you have questions, make sure you ask. So we have reflections across the x-axis. So I'm going to draw a little picture here to help me visualize it. Here's my x-axis. If I have point A up here, then point A prime is going to be down here. And we can see if we want to reflect it, what we're going to do is count the number of units to the x-axis, and your image will be that number of units on the other side of the axis. Okay, so if we want to talk about a rule, we have all of our original xy values. Okay, any x's stay x's, any y's change to the opposite of y. Notice I said the opposite of y and not negative y. Okay, so in this case my a flips below. So that's for reflecting across the x-axis. And again, these are two specific cases. Our first example, we reflected over the line y equals 2. So we'll reflect over other lines besides the x-axis and the y-axis. All right, let's start with point A over here. And now we're going to reflect over the y-axis. Again, we're going to count the number of units that we are from the y-axis and then go that far on the other side to get a prime. And our rule for this, any x, y values in our pre-image, that's the original. Now the x values are going to change to the opposite and the y values are going to stay the same. So this is a little summary. But the key here is no matter what line you're reflecting over, you want to count the number of units to that line and then go that same number of units to the other side. All right, so for the rest of the notes, go ahead and give those a try on your own. Don't forget to do the recap it. And if you have any questions, let me know, and we'll see you next time.